So, another week, another episode of Upgrade Time. Last week we were doing some improvement on the introduction of the game. So, just to remind you, we were at this point. So we had the intro sequence, a new help page, and some way to display information about the story. And I broke something, which is not surprising because I was doing some tests using a new version of BASIC to tap. Anyway, what I wanted to... Ooh, what did I do? Okay, because I was using fast forward on the emulator. Iris text. What I wanted to show was this. Print 30 give us 2325, which is the amount of free memory for the BASIC at the moment. And another interesting element is doing dir, shows us we have 16 sector frees. It's a single-sided floppy with 73 tracks on 17 sectors. Why is it important? Well, it's important because in the video game development, it's quite common that a project dies not because of lack of talent, but because of what we call budget. If you are making a game for an underpowered computer or console, you can't really afford to use as many assets, music, graph, collisions, etc. than you would on a big PC with a gigabyte of RAM and a large SSD and this kind of thing. So on the Oric, the constraints are very, very strict. Here, these constraints work only on 3.5-inch floppies. Unfortunately, that will not work at all on a 3-inch floppy. In this case, it's a Blake 7. Because the 3-inch floppies only have 40 tracks, but they can be double-sided, which means that technically 40 tracks double-sided, that will fit. So this game can be put on a normal floppy, which is nice. And we can validate that using a second tool, which I discovered recently, if I can find it. Oric DSK Manager. Open disk and build and counter DSK, and we can see in a different way the floppy we just had, and indeed it has one side, 73 tracks and 17 sectors, which matches what we have here. On here we can also see the init sequence on the fact that it actually has some sample names that I should probably change at some point. So we know it fits on disk, but we only have 2303 bytes, which may be a problem if we want to continue to develop the game. So what I did is that I did a bit of benchmarking. Because if you remember, a few weeks ago I was playing with the audio, trying to get something which runs in parallel while you type, and there were some performance problems. So I decided to give a shot at doing some benchmarking. So here are some, what it looks like. Basic benchmark. The number which is displayed here is the unit of time taken using the timers I was showing the other time, between the start of the function and the end. and I wrote a bunch of small functions with different variables and variants on how to do the same thing. And here is the time it takes by just changing a few parameters. So as you can see, I've been benchmarking for loops on single line with colon separators, on other with multi-line, with spaces, no spaces, testing the variable at the end, next I or next, equivalent with goto, and equivalent with repeat until. And I've also been playing with decimal and hexadecimal values to see if they had some performance difference. That one is using some ugly hack involving poking in memory to change the basic interpreter parameters. And this one answers the good old question of should you check key press using string comparison, or should you do it comparing the ASCII codes? And this one, go to loop top, and go to loop bottom, and go to loop center, are actually the exact same code, but at different location in memory and in the source code on how it impacts. So let's see what that looks like in the code. So up, here we have the results. So it's a very simple program. Print basic benchmark, and it uses data. And the data is a simple way of having things. So the line to run and the description. And what the program does, go to 10, go there, display thing, restore in case we want to run it multiple times, read the line, read the description. If the line is 0, print done, else reset the timer, call the function to perform what we want, compute the timer difference, display the value on the text, on the loop until we are at 0. And here we have all our function, so which match everything we have here. And the functions are very simple. So this one just does for I equal 1 to 500, next I, takes 46. Just removing the check on the variable at the end goes down from 86 to 63. Just not having to check the variable is faster. So for readability, if you have multiple for loops, it's probably more readable to have that, but if you only have simple loops, you probably should not put the variable because it takes less room, you don't have to store it in the source code, and it runs faster. These and these are the variants where instead of using a separator, it's on different lines. So we go from 86 to 88 and from 63 to 66. So you can see that it's faster to have everything on one line if you can, instead of multiple lines. Then we have the variants with space. For space, I, space equal space, blah, blah. There is two, it's a little bit slower with space, but it's not major. So you lose more time by checking the variable than by adding spaces. In any case, the space is using source code, and we have only 2,300 bytes remaining, and every 1, 2, 3, 4, 5, 6, 7 bytes, it goes very fast. Then we go to the goto variants. So that one, I equal 1, I equal I plus 1, if different 500, go to 2002. Increment and return. So technically this does exactly the same thing as the for loops, except instead of taking 80 or 60 units, it takes 959. Just doing the comparison manually instead of a for loop is a huge penalty in terms of execution time. That one is the same, but the difference is that we start using hexadecimal values for comparison. On just doing that, drops from 599 to 897. And the reason is the CPU compute in base 2, and hexadecimal is a variant of base 2, while decimal is base 10, which involves doing divide on modulos and things that 6502 is definitely not very good at. And if you wonder why I did not do that here, is that it did not matter, because the values are read once on the first execution of the 4, they are stored, and that did not do any measurable difference. Now, if the loop was in another loop, that may have had an impact, but don't brainstorm too much about that one. And then we go to the repeat until decimal, mix, hexadecimal. So that one 500, 1 F4, 1 in hexadecimal, 1 F4, which respectively takes 472, 375, 370. So same thing with repeat until. If you can put X values, do it. Then we have the magic doc. That one is, I am not proud of it. Actually, I am. Let me see. E9, E4, position pointer in program. So what that does is, at the start of my code, I store the location of the program counter, of the basic program counter in a variable, and I do the same test as what I was doing with the goto. Instead of doing goto 2012, I'm poking or docking, because it's a 2-byte value, the same value to E9, which actually makes the program do the same thing. Except it's faster. It's at least faster than the 2 first type of gotos, but not as fast as that one. I'm going to explain that later. Then we have the catch check. 3 different values, different routines, sorry. One that compare a string to some literal strings, one that compare the numerical equivalent that you will get using ASC keyword to convert a key to ASCII code, and the same one using decimal values, so 41, 42, 43 hexa is the same thing as 65, 66, and 67 decimal, which give us 694, 765, 979. So the worst case is to do computation using decimal values. The best is to do string compare. I am not quite sure why. It's probably the way strings are encoded. And then we go to the difference between that one, the goto loop at the bottom, the goto loop in the center, and the one I hide at the top here, the goto loop at the top. The bottom one takes 1019, the center one takes 959, and the top one takes 515. So that one is twice as fast as that one. And the reason is the way BASIC is structured. When you do a goto, the interpreter starts from the top of the program, and all this is a linked list of instructions. Let me see. Line format. So each line here, encoded, you have 2 bytes, which indicates the offset, or actual position of the next line, plus the line number. So here we have 0, 0, the actual content of the line, which is a remark on the end of line. So when you do go to 6001, BASIC goes there, check the 2 bytes, is it 6? No. Jump to that one by reading these 2 bytes. Check the number, is it? No. Next, 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 next. So the time it takes to execute a goto or a go sub takes a directly proportional amount of time to the number of line numbers, actual lines it has to go through. Which brings something as a conclusion, which is, if you have some subroutine which you are calling often and are relatively critical in terms of performance, you should put them at the top of the program, eventually jumping over, like what I did here. A corollary is also that the less lines of code you have, the faster the program. So if you were on the fence between this style here and this style there, well, with that one you pay the cost of 1 line of code. With that one you pay the cost of 2 lines of code, which is slower and makes the rest of the code slower, so it's probably not something you should do. So I did like last time, which is in the MISC folder, I added a bunch of documentation page. So I put the list of basic keywords, which come from the Oric manual. So every single keyword you are using is encoded in only 1 byte. So it's relatively compact. Then the way the line numbers are stored with the description, which I just showed. Description of how for loop are working and why you can't use integer values and why it takes some time. Some example about what I was talking about, using or not variable and what happens if you do it in the wrong order. The way data is stored on the stack, depending for next and go sub return. So there is a trade-off. For is much faster than both repeat until and go sub return and go to based, but it takes a lot more room on the stack. So if you are in a critical situation in regard to the amount of space, and if you want to do a lot of loops inside loops, you may have a stack overflow using for. And that's about it. I did not do anything else on the game itself, but I received the example, the Encounter original on tape, which, there you go, with a small manual. And I wanted that because I'm going to do a hardware edition, a real edition of the game. So somebody on the Defense Force forum suggested that I should call it Encounter Redux. So that's just a prototype on using the Black 7 sticker. Yeah, so it's just a prototype. I'm not sure if the name is going to stay Encounter Redux or something else. But yeah, I'm going to continue with that so far. It's not a bad name. Yeah, I think that's all for this episode. So, as usual, if you have a comment or question, just add some comments at the bottom of the video. And see you next time. Bye bye.